Hello, I'm Frode Tørresdal, a digital transformation leader at Norconsult. My experience spans extensive work with BIM, particularly as a developer. More recently, I've been working with digital twins, especially Autodesk Tandem. Welcome to this session titled Transforming Facilities, Demand-Driven Strategies and the Tandem IPA. This is the agenda for this session. I will start with a quick introduction to the Norconsult, where I work. Then I will go through the challenges of traditional facility management and how digital twins can address some of those challenges. And the final and the largest portion of the session, we will go through some case studies and examples, more precisely Tandem Connect and the Tandem Data API. And in this slide here at the left, you can see a typical screenshot from Tandem. This is our main office in Sandvika near Oslo, where we have added some sensors and added into the 3D model. Norconsult is a leading interdisciplinary consulting firm that combines engineering, architecture, and digitalization. With approximately 6,300 employees across more than 140 offices in Norway, Sweden, Denmark, Iceland, Finland, and Poland. Norconsult provide consulting services for building and property projects focusing on functional and sustainable designs. We offer consultancy and project development for renewable energy and industrial projects, including hydropowers, solar wind, and thermal power plants. And Norconsult delivers efficient and sustainable transport solutions, designing and maintaining critical infrastructure such as roads, railways, airports, and water systems. Our interdisciplinary approach ensures innovative and efficient projects that improves everyday life. And in a lot of these projects, it's also the digital twin plays an important role, or can play an important role also. Then over to the challenges in traditional facility management. Well, this class focuses on digital twins, but what actually are they and why are they so important? Let's delve into some fundamental use cases that our customers, particularly owners and operators, are talking about. One major issue we often hear about is the lack of data continuity across different phases of building lifecycle. Typically, the lifecycle includes planning, design, construction, operation, and eventually renovating during the next capital planning phase. While building information modeling has largely addressed the challenges between the planning, design, and construction phases, ensuring data continuity from design to construction, there are still gaps when transitioning to the operation phase. During the operation and maintenance phase, the handover usually consists of various documents like Excel files, Word documents, JPEGs, images, videos, PDFs, drawings, Revit models, and BIM data. The operation team, however, often struggles with these materials because they are not BIM technicians, managers, and may not understand the complexities of the detailed engineering data provided. This fragmentation of data across different project phases leads to inefficient workflows for updating and managing project information, making it difficult to maintain a cohesive project history. Another common issue is the limited BIM knowledge among those in the operation and maintenance fields, which hinders project collaboration. While those with a BIM background can easily visualize 3D data, operation teams often struggle with the complex BIM models handed over to them, leading to unused data. The design build phase is a small part of an asset's lifecycle, typically 5 to 10 years, while the operation phase can last 50 to 100 years. It's crucial to use BIM data throughout the asset's lifecycle, but we don't expect operation teams to be BIM experts. And just as Google Maps simplifies navigation without requiring users to be mapping experts, digital twins should simplify BIM data management for owners and operators. Many facility and operation managers lack the tools to visualize their facilities, leading to reduced collaboration and delays in decision making. Often data is handed over after construction, causing trust issues. Early access to project data through digital twins can build trust and ensure efficient use of BIM data beyond construction. And data handover is often an afterthought, causing stress and delays. Simplifying this process with digital twins can improve information sharing with clients and owners. So in this next session, we will take a look at the digital twin technology. What is it actually? Well, we often talk about digital twins, but do we truly grasp their significance and the value they bring? And here is an example. Graphs are incredibly useful for overlaying data and identifying patterns, providing a clear and concise way to visualize complex information. However, when we translate this data into the 3D world, it not only enhances the visual appeal by making it look realistic, but also opens up a myriad of new possibilities for analysis and problem solving. For instance, consider a scenario where there's a heat-related issue within a building or an industrial plant. In a traditional 2D graph, we might see temperature spikes and trends, but it can be challenging to pinpoint the exact source of the problem. By using a 3D model, we can visually trace the heat distribution throughout the entire system. This allows us to follow the heat flow back to its origin, whether it's a malfunction piece of equipment, a blocked vent, or an area with poor insulation. This 3D visualization enables us to understand the cause and effect relationship much more effectively. We can see how different components interact with each other in real time, identifying potential problem areas before they become critical, and make more informed decisions about maintenance and repairs. Additionally, this approach can be used for training purposes, helping operators and technicians to better understand the systems they work with and improve their troubleshooting skills. Overall, translating data into the 3D world not only makes it more engaging and intuitive, but also significantly enhances our ability to analyze and address complex issues. And I'm not saying that graphs are obsolete. They still offer great potential for overlaying multiple data points and gaining insights. However, adding a contextual aspects like heat maps can pinpoint exactly where you need to focus. This enhances both communication and understanding of the data. And here is an explanation of what Autodesk Tandem is. That is the main topic of this speak, and also is the project that Autodesk delivers that handles the digital twin. Autodesk Tandem is one of the platforms that addresses the challenges with traditional facility management. Autodesk Tandem is a cloud-based platform designed to transform the build asset lifecycle. It enables AEC firms to harness data through the project lifecycle, facilitating the creation and handover of a digital twin. Additionally, Autodesk Tandem helps owners connect operational systems to the digital twin, transforming fragmented data into valuable business intelligence. And Tandem is great on its own, but it's even greater when you connect other systems to the digital twin. And one technology that helps with that is Tandem Connect. When I began working on this presentation, Tandem Connect was still in its beta stage. However, this is no longer the case. It is now a released product. And this is a no-code, low-code solution to connect other systems into Tandem. And there are two main challenges to making digital twin repeatable. The first challenge is ensuring that you have clean and accurate asset data, which is achieved with Tandem. By integrating multiple models data from various sources into Tandem, you can define your assets and leverage Tandem's capabilities to perform powerful queries using dashboards within your facility. And the second challenge is establishing bidirectional connections to the numerous solutions an owner uses in their operational ecosystem. This connectivity brings the digital twin to life by linking it to data streams from various sources. And Tandem Connect technology plays a crucial role in bridging this significant gap, enabling seamless integration and enhancing the functionality of digital twins. As you can see here in these slides, there is integration for a lot of systems that is used within the digital twins, like SAP and Oracle and IBM, Maximo, Siemens, and there's a lot more. Autodesk Tandem Connect is an integration platform designed to establish bidirectional connections with enterprise systems for maintenance, space, and financial management, as well as building management, IoT, and other control systems. It empowers users to connect various systems, integrate data seamlessly, and automate workflows efficiently. Tandem Connect allows customers to author integrations that may include complex data information using a low-code environment. It includes a rich library of both pre-built solutions and plugins for existing systems such as IBM Maximo and SAP. SCADA control systems are interfacing with systems that use protocols like MQTT and BACnet. Pipelines can be deployed to execute in the cloud, at the edge, or in a hybrid environment. To give you an idea how this works, let's run through an example where we use a free Norwegian weather service where we can get both current and historical weather condition. A use case can be to visualize the impact of weather conditions on a digital twin you are monitoring with respect to other data you are also gathering through other sensors. We start with scheduling how often the flow should run and send data to Tandem. Could be every minute, once per hour, or once a day. It's your choice. And then we call the HTTP service, getting the weather data from a specific location. We see how this can be done in this slide. It's just a simple URL call. We then transform the data from the weather service, typically with some simple script, to a format that we can send to Tandem. And finally, we use the Tandem connector to send data to Tandem. Here we specify what facility to send to. It is also important to notice that to send data to Tandem, you need to have defined an APS app and that the client ID and secret must be set in the Tandem connector along with the Tandem facility ID. And when the flow is set up, it automatically appears in the specified Tandem facility. All the sensor information in one portal makes the digital twin both repeatable and accessible. And before Tandem Connect, we typically used Microsoft Azure IoT. It's a lot of different Azure services to set up and questions about who should own the Azure account, who will administrate it and maintain it, and what will it cost. Using Tandem Connect takes away a lot of those technical pains. You don't have to maintain the code. Everything is maintained by Autodesk. The one pain that still remains is to get access to the sensor data from the building owners. And do not underestimate how difficult that could be. Now we use a lot of more time actually, to get the access to data than actually setting up the digital twin. So to go and repeat this, I have a video here that shows how this is set up in Tandem Connect. First, we schedule the data, we set a name for it, and we set the scheduling here every 30 minutes. This will run. And then we set up an HTTP service. And here we give it a name. And we paste in the URL here. It's the URL for, this is not a Norwegian weather service, it's another one. But it has the longitude and latitude. It's a very simple URL for calling this service. We add an authorization. And then we have to convert the data. This is a little script, just converting the data to a format that is suitable for Tandem. You can see it's very simple JavaScript here. And then we use the connector to send data to Tandem. We just give it a name, client ID, client secret, and the facility ID. We get that from Tandem, and we can also set the classification here so that it gets classified. And afterwards, we can just test this flow by syncing it, and then we will see here that in the log that data has been sent in this format, JSON format, to your Tandem digital twin. And if you go into that to Tandem, you will also see that this data has been received, and it is also added to the component. And in this final section, we will touch on the Tandem API. While it may seem a bit more complex at first glance, it's not as complicated as it initially appears. The Autodesk Tandem API effectively bridges the last gap in digital twin technology, offering unparalleled access and control over your building data. You can now read and write individual properties attached to your asset, which allows for granular management and updates. You're also able to assign classification to assets, which ensures better organization and searchability within your digital twin. And working with levels and spaces is now easier than ever, streamlining the navigation and management of your facility's digital representation. And furthermore, the API allows you to create streams and import data from IoT devices, enabling rich visualizations and real-time insights. And finally, you can seamlessly integrate with facility management systems and other mission-critical applications, which ensures a holistic and connected ecosystem for your building operations. And as we can see here in this slide, at the right, there is quite a comprehensive developer guide that you can use to get started with the API. So why integrate with an API? With the Autodesk Tandem API, you can enhance data interoperability through seamless integration with BIM, GIS, and IoT, and operation maintenance platform. This avoids data silos by enabling real-time data exchanges and ensures consistency across different software and stakeholders. You will gain real-time monitoring and analysis by connecting IoT sensors for live performance tracking. You also enable predictive maintenance with AI-driven insights and optimize energy efficiency and operational workflows. The Autodesk Tandem API improves collaboration and workflow automation. It streamlines communication between project teams, automates reporting and documentation updates, and enables remote access and real-time decision-making. And ultimately, this leads to significant cost and time savings. You'll reduce manual data entry and potential errors, improve project scheduling and resource management, and minimize downtime with proactive maintenance alerts. So now I will walk you through a simple example to demonstrate how the API can be used to connect to a facility management systems. In this case, I will be using Easy Eiendom, a product developed by Norcasol Digital, but the principles apply to any systems that has an API. This image is a screenshot from Easy Eiendom showcasing various types of information related to an asset. It includes details such as work orders, maintenance schedules, and other critical data. And by connecting to the API, we can seamlessly integrate this information into our digital twin, ensuring that all relevant data is accessible and up to date. And through this integration, facility managers can gain a comprehensive view of their assets, streamline operations, and make more informed decisions. The API connection allows for real-time updates and data synchronization, which is crucial for maintaining the accuracy and reliability of the digital twin. And to effectively integrate your Tandem facility with your facility management system, it's essential to configure the Tandem facility with appropriate parameters and facility templates that aligns with your management system. This ensures that all assets are properly classified and organized. This classification process can be automated. In my case, the facility management system, ECIndom, uses the IFC GUID for all assets. And this unique identifier serves as a key, allowing the system to accurately match and locate the same assets within Tandem. And by leveraging the IFC GUID, we can ensure that the asset data in Tandem corresponds precisely with the data in the facility management system. This synchronization is crucial for maintaining data integrity and ensuring that all information is up to date and consistent across both platforms. And as we can see here in this image, it's a rather old projector from the 1980s that has been replaced and updated in the facility management system. And to begin, you need to create an APS app and add it as a user to your Tandem facility. This step is crucial for enabling the integration and functionality of the API within your facility management system. And once the APS app is set up, you can utilize the API to interact with various elements such as levels and spaces. Additionally, you have the capability to create data streams and import information from IoT devices, enhancing the visualization and richness of the data. This is similar to what I achieved with a Tandem Connect, where IoT or the weather data was seamlessly integrated with a more comprehensive view. However, for this demonstration, the focus will be on connecting the API with the facility management system. And this integration allows for real-time data synchronization and ensures that all relevant information is accessible and up to date. And by connecting the API to the facility management system, you can streamline operations, improve data management, and enhance decision-making processes. Overall, the API provides powerful tools for managing and visualization data within your Tandem facility, making it an invaluable asset for modern facility management. So I will demonstrate what I consider the 5 most important endpoints for reading and updating data in Tandem. Typically, these endpoints would be used within an app, but for this demonstration, I'll show the REST calls in a program called Postman that I use for testing REST API endpoints. And the first step is to find the model ID. To do this, use the getTwins twin ID endpoint. You can copy the twin ID from the Tandem facility URL. This endpoint will return the model ID, and we will use this in the other calls. The second step is to find the IDs of Tandem properties. To do this, use the model data get schema endpoint along with the model ID from the previous step. This endpoint will return all properties of the facility and their IDs, identifying the property you want to update from your system and make note of their IDs. And as we can see here, this is the ECIndom property that we want that has this IDs that start with set. The third step is to get all the assets in Tandem. To do this, use the model data post scan endpoint. Specify which families of Tandem properties to search for. Set the keys arrays to empty to find all assets. The first thing to understand is the structure of the Tandem data model. Imagine it is a sparse 3D matrix where rows are elements in the model, columns are attributes, and the third dimension is the history of values that property has had over time. And the column or the attributes are grouped into families, each of which is depicted by a hard-coded character specification. How this works is explained in details in the documentation. I will go briefly through some of those here. In this case, we added a few of those families. The letter N is common property that is available for all elements. And L reference to other elements, typically type, level, or space. And X reference to elements in other models. R are properties that come from source model files like Revit or IFC models. And set is user-defined parameters. That is what we will look at here. When I executed this call, I retrieved the assets tandem key that is used to connect the assets in tandem with the facility management systems, and that is the IFC GUID. As you can see, it's the K here that has this IFC GUID. And the next step here involves retrieving the properties of an asset in tandem. And that is the asset that I found in the previous step. And to accomplish this, use the model data post-scan endpoint, specify the families of tandem properties, and set the assets keys in the key array. And that is the key from last step. In this case, I could have used just the set, the user-defined family, but I added all just to show how it works. And this will return the values of the tandem properties of the specified asset. The property IDs can be found using the get schema endpoints shown earlier. As we can see here, we have this, that the date of this projector, you have the name and the date here, and that is we can see that this is the old one from the 1980s. And finally, to update the property of an asset, use the model post-mutate endpoint. Set the asset key for the asset you wish to update and define the new value for the property. And you can update multiple properties in one single call. In this example, we just update one asset. And if the update is successful, you will receive a timestamp and the values will be instantly updated in the tandem model. If we go back to the model, as we can see here, the data is updated. The old projector from the 1980s is updated in the digital twin with a new one. And the only place you need to maintain this is in the facility management system. The digital twin will then be automatically updated. The landscape of facility management and building design has undergone a remarkable transformation with the advent of digital twin technology. And as we explored through the capabilities of Tandem Connect and the Tandem API, several key insights emerge. Technology is here connecting entire building lifecycle. Digital twin solutions now provides a continuous digital thread throughout the facility's existence, from initial design through construction, operation, and eventually renovation and repurposing. This seamless connection eliminates the traditional data silos that have long plagued the industry, creating a single source of truth that evolves alongside the physical structure. The way we communicate with stakeholders has changed. Gone are the days of complex technical drawings that only specialists could interpret. Today, digital twins offer intuitive visualizations and interactive models that democratize information access. Everyone from executives to maintenance staff can engage with buildings data in meaningful ways, fostering better collaboration and more informed decision-making. And it's easier than ever, not only to create, but easier to reuse and maintain. The evolution of platforms like Tandem has dramatically reduced the technical barriers to implement digital twin technology. What once required specialized expertise now follows streamlined workflows, making digital twins not just practical for implementations, but sustainable for ongoing use. The ability to reuse existing models and easily update information means that the digital representation remains relevant throughout the building's life. And even more data to Tandem with no coding using Tandem Connect. Tandem Connect represents a significant leap forward in accessibility, allowing non-technical users to integrate diverse data sources into their digital twins, from IoT sensors to building management systems. These connections can be established throughout intuitive interfaces rather than complex programming, expanding the potential use space and applications. And even further, and add everything you can possibly think of with the API. For organizations with more special needs, the Tandem API opens up unlimited possibilities. This programmatic access enables custom integrations with enterprise systems, advanced analytics, and innovative applications that extend beyond standard functionality, all while maintaining the core benefits of the digital twin ecosystem. The convergence of these capabilities signifies the digital twin technology has moved beyond theoretical promise to practical implementation, transforming how we design, build, and manage our built environment. Thank you for your attention. I hope you found this presentation insightful and useful.